Hare Krishna to everyone. So here we have declared our GPIO drivers for GPIO init and read from port pin, write into port pin and toggle that pin. So we need to give this definition of the each drivers API. So just open our STM32F44X GPIO driver.c. So we have already created that file. So just open that file, and in that file we need to give some format. We have our format, so we'll declare in that format. So this is our format. First is our file name, so this is our file name, and this is our author, like we are Embedded Galaxy team. And in this one we'll define our GPIO driver APIs. Okay, everything for initialization and GPIO init and output. So everything will define in this file. Okay, so so this is description for each function prototype. We have these functions, so each one we need to give some functional description, like this is our GPIO init. In that one we need to initialize our GPIO peripheral according to the specific parameter in the GPIO init. Okay, and this is our parameter we need to pass our handle structure, and this there is a no return time, so we'll give as a null. Okay, so first what we need to do, we need to include our file. So I'll include stm driver.h file. Okay, so this is our header. So this is our include file. Okay, and the first we need to define okay, so we'll define this file. First is our GPIO init. Okay, so we have different pin configuration here. If you open driver.h, so we have to select the mode. Like we have different modes, like we have analog mode, we have alternative function mode, input mode and output mode. So first we'll define the mode. So what we'll do, we'll create our first our switch case for this is our pin configuration. Okay, in that one what we'll do, first we'll give this is our handle. At handle we have our GPIO configuration pin. So in that handle we have our GPIO configuration. Okay, and in that one we have our GPIO pin mode. PIO, let's go. Yeah. So in that one we have this one, GPIO underscore pin mode. Okay, so we have what are the modes we have possible. So we'll write that cases here. Okay, first case is here, first is here. First mode is our GPIO analog mode. Okay, or first you can give this one also. First is our input mode. So in the input mode we'll whatever the things we needed, we'll declare that one. Just whatever the modes we have, so we will write that first, and then we have output mode. and then we have alternative function mode. Okay, then we have analog mode. And we'll keep our default so what we will first what is the GPIO mode, input mode. So what are the configuration in the GPIO register we'll do first, and then we'll do our output mode, and then alternative function mode, then analog mode likewise. One, the reference manual. So in that one, just go to our first is our mode, input mode. Go to the model register, and here you can see for mode, for input mode you need to reset these 2 bits. For each port they have given us the two bits for each ports, for each pin. Okay, like 0 0, if you place 0 0 in the pin 0 section, that pin will act will be in input mode. Okay, and if you place if you set that first bit is 0 and 0 bit is 1, then that will act as a output mode. Okay, likewise 1 0 and 1 1. So for each model register they have given us 2 bits, and we need to configure that bits according to our GPIO pins. Okay, so we need to reset 2 pins. So for resetting 2 pins, what we'll do, so first we have our handle structure. So in that one handle we have our port register, that is this one, and then we have our model register. So you can see here, if you go in the .h file, we have first is model register. Just go that model register, and in that model register what we need to do, we need to reset that bit. So for resetting, if you write 1 1, 1 1 means value 3, 0 cross 3, that is the value, and we need to uh, uh, shift that pin actually. Okay, so we need to shift that pin accordingly. So this is our handle structure. In that handle, what we need to do, we need to get this configuration, and then we need pin. Okay, so what we have done right now, 0 cross 3 0. If you 1 1, this is 1 1. Okay, if you 1 1, if you shift with that respective pin number, so in the reference manual you can see we have 2 bits, so you need to shift according to 2 bits. So first pin you need to shift according to 2 bits, so we need to multiply 2 here, because they have given 2 bits for each pin. Okay, this is our pin, so that pin you need to shift and you need to reset that pin. Okay, so this is our input mode. So in the input, you need to reset that pin. Okay, and then we have our output mode. So this AND and negation, it will reset that value. Okay, but actually this is our register, so we don't know what the value inside the register. For each, what we need to do, we need to reset that value for each pin configurations actually. So we'll so if we reset, so definitely the value is 00 inside. Okay, so and then if you reset that value, then you can write whatever the according to the modes, like output, you can write that value. So the programmer can understand easily that value is written perfectly. Okay, then we have output mode. In the output mode, what you need to do, you need to, so just take this model register, and that model register output mode, what we have to do, we have to write, just open reference manual. That reference manual, for output you need to write 01. 01 means 0 cross 1, so you have to write 0 cross 1 in that position of that pin number. So this is our uh, pin. So you need to multiply by 2, because 2 bits are dedicated to that mode or register. So if you shift by 2 and 0, if you write 0 cross 1, 0 cross 1 means 0 1. If you write 1 in that bit field, so it will configure as the output mode. Okay, similarly for alternative function mode, you need to write 10. 10 means 2. Okay, so for alternative function mode, you need to write 0 cross 2. Okay, so this is your handle, and this is your GPIO port, your GPIO registers can access from here. And this is our pin configuration. You need to shift that pin by, if you need to multiply by 2, and in that 2 bit, according to that pin number, you need to write what you need to write 10. Okay, and then we have, for analog mode, you need to write 11. For analog mode, you need to write 11 means 0 cross 3. So it will shift that bit of bits, and it will write 11 according to your pin. Okay, this is our analog mode. So we have configured our mode, and right now we'll configure our speed register. So second one is our speed register. So we'll configure our speed register. Right now we have our speed register. For speed register, what we can do, first what we'll do, we need to reset that value inside the speed register. Okay, so this is our handle structure. That handle, this is our register, GPIO register, and the speed register you need to reset. So actually, if you open the manual, so speed register also they have given 2 bits. So according to that, you need to give this configuration for speed register. Okay, So what we have to do right now, for low speed you have to give 0 0. So already that register was 0 0. If you reset that register, it will give 0 0. For medium speed, what you need to do, just take this one and do OR operation. So in that field you need to write, first is our medium speed. Okay, so you have to write 1, and if you shift by 2 bit that pin, and if you write 1 1, it will give medium speed. For fast speed you need to give 1 0. 1 0 means 2. So likewise, so you have written 2. Okay, and for high speed you need to give 1 1. 1 1 means 3. So this is our output speed register. So here inside you need to give this macros. So low speed, medium speed and high speed. According to that you need to configure that pins according to this manual. Okay, so then for push pull, just open the our pull up and pull down register. In that one we have 0 0 for no pull up, 1 0 1 for pull up, and 1 0 for pull down, and 1 1 is reserved. So you need to configure the 3 pins. So you can use the switch case again for our pull up and pull down configuration. You can write pull up and pull down. So if you take pull up and pull down control, and these are the macros, you need to define the you need to open the reference manual, and according to you need to set that bit. So 0 0 stands for no pull up and pull down. So this is our first we need to reset that bit before setting. So just reset that bit. So this is our pull up and pull down. Just open the reference menu, just open the registers map. So this is our pull up and pull down. Okay, so in that one we have 2 bit for each pins. So in this one, if 0 0 means no pull up, 1 0 1 means pull up, and 1 0 means pull down. According to that you need to set. So right now we set at 0 0. So this is means there is no pull up. And for pull up and pull down, so need to reset first now. Okay, so in that one position we need to write 0 1 for pull up configuration. First is 0 1. Okay, then 2 for pull down. So then we need to write 2. Okay, this 2 means 1 0. So 1 0 means that is pull down. Okay, so we have declared our configuration of pull up and pull down pin configuration. And then next what we have, output type. Okay, so in the output type, just open the reference manual, So just open output type. So 0, and 0 means push pull output type, and 1 means open drain. So we need to give only two fields we have. First is our push pull, and then open drain. Okay, so for push pull, you can define switch case, or you can define else if also, or depends on what are the configuration you need. And if that pin, if that output type is push pull, so we have one dedicated register, so we need to shift according to one position. No need to shift for 2-bit position. You need to shift according to one position. Okay, so first what you need to do, you need to reset that bit. You need to reset that bit. We have resetted that bit according to that pin. This is our output type register, so this is our pin, so we have resetted our bit, and 0 means already output type is a push pull, and then we need to reset that bit, and we need to set that bit actually. So 0 1 means you are setting that bit in that output type register according to pin shift. Okay, so this is our output type. So open drain, and you are shifting that bit to one position. It will shift that bit. Okay, if you open again reference manual, so if you write 1 in that section, if you write 1 for pin 0, so it will act as a open drain. If you write 0, it will configure as a output push pull. Okay, so complete up to here. So alternative function mode we'll see in the next.